All right, let's jump right in. We're going to break down the journey from just, using Python to truly mastering it, pulling some amazing insights from Rick Fonham's book, Mastering Python. You know this feeling, right? It's that moment it clicks. You've been getting by, but suddenly you want to go deeper. You want to understand not just what the code does, but why it works the way it does. That's the quest we're diving into today. So you might think the path to mastery starts with some super complex algorithm or design pattern, but it actually starts somewhere much more humble, but honestly way more important, setting up your workspace like a pro. And that professional setup really rests on three pillars. First, you've got to supercharge your basic Python interpreter with something powerful like IPython. Second, and this is a big one, you have to isolate every single project with virtual environments. And third, you need to get a handle on managing different Python versions, which is where a tool like PyEnv is an absolute lifesaver. Look, virtual environments are they're non-negotiable. Seriously. They give each project its own little sandbox, which stops that nightmare scenario where one project's libraries start conflicting with another's. But check out this pro tip from the book. He actually advises against putting the environment folder inside your project. Instead, keep them all in one central spot. It's a cleaner approach in the long run. Okay, so your environment is solid. Now the game shifts from how you run the code to how you write it. And this is less about rules and more about a philosophy, about writing Pythonic code. Code that just feels right in Python. Clear, readable, and elegant. This right here, this is one of the commandments from the Zen of Python. And it's your guiding star for writing great code. What it really means is, don't make people guess. Make your code's intention obvious and clear. And here is a perfect and, frankly, kind of scary example of why that matters so much. On the left, with those star imports, if you call wait, where is that function coming from? Is it from OS, asyncio? Who knows? It could change depending on the import order, and that's how you get some really terrifying bugs. The code on the right, os.wait. No doubt, no ambiguity, it's safe, it's clear, it's professional. Now, when it comes to dealing with things that might go wrong, Python has a certain style. It often prefers what's called EAFP, or easier to ask for forgiveness than permission. So instead of checking first if a dictionary key exists, you just go for it. You try to access it. If it's not there, Python raises a key error and you just catch it and handle it right there. It's usually cleaner and more direct. Okay, let's get down to the absolute building blocks of any program, your data structures. Anyone can use a list, but a master understands the subtle differences that make a tuple or a set or a dictionary the perfect tool for the job. The classic showdown, list versus tuple. It all boils down to one single concept, mutability. Can it be changed? Lists are mutable. You can add to them, remove from them, change things around. Tuples are immutable. Once you create one, it's set in stone. And that one little difference changes everything. And here's why that matters so much. This idea of hashability. Because a tuple can't ever change, Python can give it a permanent ID card, a hash value. That's what lets you use it as a key in a dictionary. A list, on the other hand, could change at any moment, so it can't be trusted as a key. Getting this concept is a huge step up. And we're not just stuck with basic collections. Python has these incredibly efficient tools called generators. See, instead of building a massive list in memory all at once, a generator, using the yield keyword, is lazy in a good way. It produces items one by one, only when you ask for the next one. All right, so your code is clean, it's Pythonic, it's well-structured, but is it fast? Is it efficient? When we start talking about performance, there's one golden rule that you just can't ignore. This right here is the mantra you need to live by. Your gut feeling about what's slow in your code is probably wrong. You have to use a profiler to get actual data on where the computer is spending its time. Don't guess. Measure first, then optimize. Always. And boom! This is where that whole lazy generator idea pays off in a massive way. Remember that? Look at this chart. To handle 10 million numbers, building a list in memory eats up almost 90 megabytes. The generator expression that does the same job? 128 bytes. I mean, that's not just better, that's a whole different universe of efficiency. It's a total game changer for big data. Now, this table is basically a cheat sheet for making your code do multiple things at once. It tells you exactly what to use and when. If your program is spending most of its time just waiting, like for a web page to load, async I/O is your friend. But if you need to do some heavy-duty number crunching and use all your CPU cores, multiprocessing is the only game in town, because it gets around a thing called the Global Interpreter Lock, or GIL. So we've covered the language, the philosophy, the performance, but let's zoom out. A huge reason Python rules the world right now is its incredible ecosystem of libraries, especially when you get into science, data, and AI. At the very heart of it all is what people call the scientific stack. You've got NumPy, the absolute bedrock for fast numerical arrays, then SciPy layers on a ton of science and engineering algorithms, Pandas gives us the amazing data frame, which has changed data analysis forever, and Matplotlib is the granddaddy of all plotting libraries. And that core foundation makes the modern AI world possible. Scikit-learn is your go-to for pretty much all general machine learning. Working with text? Check out Spacey. For deep learning, the two titans are PyTorch and TensorFlow. A master knows this landscape and knows which of these incredibly powerful tools to pick up for the problem at hand. So as you can see, the whole journey is about building up this deep, nuanced understanding. It's not just memorizing syntax. It's about developing the wisdom to look at a problem and choose the right tool from this massive, amazing toolkit. And that really gets to the core of it all. True mastery isn't about using the most complicated, fancy feature you can find. It's about understanding the trade-offs. It's about knowing when a dead simple script is the most elegant solution, and knowing when you actually need to bring out the big guns of concurrency or a massive AI library. So that leaves us with this final thought. This balancing act is really the heart of the craft. As you go down your own path, how do you balance Python's beautiful core simplicity against all the incredible and sometimes incredibly complex power that the ecosystem gives you? That's the question every master wrestles with, every single day.